the back side of your paper, we're about halfway done. And mostly everything else that we're going to be doing is the same as what we were doing before. We just have one new principle to add to it. Okay, and it's going to affect how we combine some of our like terms. Now we said that in order to add fractions, you need the same bottom. But what if the bottom is different? What do you have to do? Well, because we use factor trees so much, let's check out to see what we can do. In this first example right here, right there, you see, oh, okay, those denominators are not the same. Well, let's see what each one is made up of. Okay, 6 is 2 and 3, and 4 is 2 and 2. Okay, now they both need to be the same. So what's missing from each one? Well, from the second one, we see that there should be a 3. Okay, so they have to have the same factors for both of them. Okay, so the second one is missing a 3 as a factor. Okay, so we're going to need to add a 3 to that second one. To the first one, we see that it has a 2, it has a 3, but it needs to have 2 2's. So we'll add a 2 to the first one. So here's how it works out. The first fraction was missing a 2. Okay, there was only one 2, and the second one had 2 of them. So what we're going to do is multiply the first fraction by 2's. So we'll have 2 over 2. And then that's going to be times 5 over 6. Okay, so that was our original. We're just adding in the missing parts from the denominator. Okay, the second fraction was missing a 3, so we'll multiply it by 3 over 3 times, and then our original fraction was 3 over 4. Okay, so you think about what's missing from each denominator, multiply them. Now you can, when you have this far, you know, the first half, on top you're going to have 2 times 5, which is 10, over the bottom is 2 times 6, which is 12, and then that's plus 3 times 3, which is 9 over 12. Okay, so 10 over 12 plus 9 over 12 is going to be 19 over 12. And that's your final answer. So let's look back at what we did. First thing, when the denominators are not the same, you use a factor tree to split it up. See what factors they have and what factors they're missing from each one. Okay, and so if one of them has more factors than the other one of a certain kind, you have to multiply top and bottom by what's missing. Okay, this will work the same for number 1. Okay, that was just our example to help us understand how to do it. Number 1, we have 3 over x plus 2 over 2x. Well, think about what's missing from each one. Okay, 2x, the two factors are 2 and x. X is just x. So what's missing? The first fraction needs a 2. See, the 2 that we have in the second one is not in the first one. So we'll multiply the first fraction by 2 over 2. Plus, the second fraction already has both factors. So we'll keep it the same, 2 over 2x. Okay, so 2 over 2 times 3 over x plus 2 over 2x. When we combine that first fraction together, 2 times 3 gives us 6 over 2x, and then plus 2 over 2x. Right? Now, combine your like terms. Now that the denominators are both the same, they're both 2x, just add the tops together. So you'll have 6 plus 2 over 2x. 6 plus 2 is just 8 over 2x. 8 over 2x. Now that's your final answer. The next one seems like it's a little bit harder, but it's the same ideas, maybe just one more step. Okay, now the denominator of the first one, x squared, is just x and x. The second one, 3x, is just 3 and x. So we're missing a 3 from the first one, and we're missing an x from the second one. If we had that, they both would have exactly the same factors. Okay, so whatever factor is missing, you have to multiply top and bottom by that missing factor. Which means that this first one is going to be 3 over 3 times 5x over x squared. Okay, we were missing the 3, so 3 over 3 times 5x over x squared. That's minus what was missing from the second one. What was missing from the second one? What factor was missing? Well, we already said that the x was missing, so we're going to multiply top and bottom by what was missing, and then whatever was left over, 2 over 3x. Okay, so for each one of these now, you have to combine your like terms. And also multiply both the fractions together. So for the first fraction, we'll get 15x, 3 times 5x is 15x, over 3x squared, which is our common denominator. That's minus 2 times x, or x times 2, which is 2x, over 3x squared. Okay, combine your like terms. On the top, you'll have 15x minus 2x. 15x minus 2x. That's equal to 13x. Okay, the bottom just stays the same. 3x squared. Circle it, and you're done.